That's the first thing, right? So it says like you want to version control something, but what is that something? Now here that something is your files which are developed by your developers, right? Now let's say what is the best example of version control system, why I need version control system in my place. Now let's imagine that you are a developer currently, so whenever you're working with git, right, you always need to think from developer's point of view, right? You should always think from developer's point of view. First thing, let's say you have developed one particular code, right? You wrote around 600 lines of code today, right? Imagine that if not, I'll just take one diagram. And recording it. Yes, it's recording. Now, let's say you wrote one particular file and that has having some lines of code. Let's imagine this is one particular line, this one particular line, and you wrote some particular versions of lines of code here, right, as a developer, right? And imagine that this one line is indicating 100 lines of code for time being, right? Right. So this one line indicates 100 lines, and this you wrote on day one, right? This you wrote on day one, right? Then on the second day you wrote another 500 lines of code. Let's imagine this is your first 200 lines of code, and on day two you wrote from 2 to 700 lines of code, right? And on day 5, let's imagine you went for 5 days and you are working on the same file, right? On day 5 you wrote code from around something like 900 to something like around 1200 lines of code, right? Now currently almost like some time went ahead and you are currently on day 20, right? You are on day 20. Now after doing some work, you thought that the lines of code which you wrote on, let's say what is this day some 5 or something like that, right? Let's imagine this is day 5. Now the lines of code which you wrote here are completely wrong, right? The lines of code which you wrote are completely wrong. Now you want to go back to that version, but will you remember if out of, let's say this is something like 25,000 lines here, right? Completely you are having some 25k lines. I mean 25,000 lines. Now if you will you remember like on this 20 days you wrote 25,000 lines of code. Will you be remembering that I wrote these lines of code on this particular day? No, right? It would be very tough to do that, right? That's the reason why we got version control system. Now I want to maintain versions for the file which I am writing. For this code, I want to maintain my version. What happened on day 1? What happened on day 2? What happened on day 5? What happened on day 20? If you want to maintain this version control systems, then that is where you get the concept of a version control system. So basically a version control system is going to track the changes which you made along from this certain time of time, right? I mean like in this point of time you want to go to history and you want to go to forward as well. You want to go to and fro from different points of time. That's what basically a version control system is used for, right? It makes sense, right? So best example for version control system is you got your, what do you say, resumes, right? Resumes are the best example. Are your resumes going to be same across all the years? No, right? It keeps on changing from 2010 to 2012 to 2015 to 17, right? You always keep on adding some particular changes. Similarly, why I'm writing source code? To make my applications work. And I know that my applications are always going to go forward, right? I mean, like there are going to be some new features, there are going to be some bug fixes, right? If not, there are going to be some new implementations at all, right? For which I'm always changing the code. Now I want to track that code because I want to say like, okay, this is the bug which occurred at this point of time. Now if I go to this point of time and if I change that bug, that is done. But let's say you developed entire project and you're not sure where the bug is present, right? If you have version control system, you can maintain that particular history of the project, right? And it says the same thing. What's the version control system? Is software that helps your software developers to work together and maintain a complete history of their work. Now, what is the meaning of working together? Right? Let's see what is the meaning of working together. Now, let's imagine. So, like, just take that particular thing. This is very important, right? A version control system helps your software developers to work together and maintain a complete history of their work history, right? And now, what is the meaning of working together? Let's see. This is also very important concept. Paint application. Let's, right. Now, let's say whenever you are developing projects, right? So, is it going to be one single developer who does all the work? No, right? We are always going to have set of developers who collaborate with each other and do the particular task. Now, let's imagine that you are working on one project, right? Let's say there are completely some three developers with you, right? So there is your developer one, there is your developer two, and there is your developer three as well, right? Your three developers. Now let's say they are working towards one common goal. Let's imagine that we are developing an application where let's say you are adding some employees, deleting some employees, editing some particular employees. Now imagine that your developer one, he is working with adding employee logic. This particular developer two is working with let's say editing employee access. I mean like editing the employee, and this particular developer is working on deleting the employee. Three different phases, right? But this application is only going to be done when all the developers work is put together, right? So let's say, so my particular application is only going to be done when I have my developers, sorry, my developers code one, my developer two code, as well as my developer three code. If I have all these pieces together, then only I'm going to have my application working fine, right? Isn't it? That's what I need. So whenever you want this kind of collaboration, that time also Git is going to help. So your developer one, whenever he does his work, he's going to push to this particular place. So I'll talk about this place. So generally we call them like repositories. Right? A simple word is a repository where you generally store the code. Right? Now, you see, you understood, right? What's the meaning of working together and also maintaining the complete history of their work. And when I go back, next slide, you see, there are two kinds of version control systems, which is very, very important as well. Right? So, one is called a centralized version control system. And the another type of version control system is called a distributed version control system. Right? So you see that centralized version system uses a central server to store all the files and enable the team collaboration. Right? And it says, but the major drawback for centralized version control system is a single point of failure. right? So I'll talk about what is the meaning of this single point of failure. Now let's say what I said, centralized collection system, I'm like the CVC, it works based on your single points. So now what is the meaning of the single point? Says, now let's say you are pushing this code, right? In your centralized version control system, you are only going to have two places, your developers, your, what do you say, your central server. Now, centralized version, and what it says there is something called like a central server. Now, this location is called your central server. This is your central server. Now, single point of failure. So, whenever you want to push, right? Let's say if something goes wrong and the connection is cut. Done. This is the best example of single point of failure. Now, whenever the connection has been cut from the central server to your clients, there is no work for your developers to do. They are completely dependent on central server. In centralized version control system, you are completely dependent on your central server. This single point of failure, so it can be anything. So it can be something like a network failure, right? It can be a network failure, or it can be your server crash down, right? It can be some power issue. Anything out of these particular issues. So whenever there is the connection cut between your clients and your server, you cannot do any operation. So basic, what is the operation we are doing here? Pushing the code, pulling the code, right? Let's say now developer wants developer 3 code, right? Now he needs to pull the code from here, right? I mean like your developer 3, I mean like your developer 1, he wants the code from your developer 3, right? He need to pull this code into this machine. Now all these operations would be down if your central server is down. I mean like single point of failure. It can be your server down, network down, power down, anything. Because it is completely dependent on this particular layer. But whereas your distributed version control system, you see that does not rely on central server. It identified that problem. Okay, the problem is that if I am completely dependent on my central server and if my central server goes down, I am worthless. Now let's say if your central server is down for 3 hours, all the developers in your organization are free for 3 hours. That's the major disadvantage with a centralized version control system. Right? And you see that it does not rely on central server, and that is why you can perform operations when you are offline. So if your server is down, if your power is not there, let's say if there is no network, you can achieve all the things on your machine itself. And you require network connection only to publish your changes. I mean like now let's say in this model, if your network is back, right? So let's say currently server is down or server is crashed. You implement a new server and you get your network back, then you can push it. Let's say your network back, then you can push it. If your power is back, yes, you can push it. Right? This is possible with your distributed version control system. Right? So whenever I'm going for distributed version control system, I can avoid this single point of failure. So you understood, right? What's the meaning of single point of failure? So whenever your network or power or any particular server has been crashed, you cannot do any operations that you can avoid with a distributed version control system. So why I'm talking about distributed version control system? Because your Git belongs to this category. Your Git belongs to something called like a distributed version control system, right? Now you see, yeah, take it down if you want like. So this is fine, right? centralized version control system and distributed version control system. Now, let's see how your centralized version control system works first. Then we'll go back to the distributed, because first you need to understand what is centralized, then we'll go to the distributed version control system. Right? So here, right, and you see that we got something called like how a normal version control system behaves, right? So earlier we used to have only two tree architectures. Two tree in the sense you were currently what we did. I mean like centralized version control systems. All your two tree architecture, I mean like whatever the version control system which is going with two tree architecture is called your centralized version control system. Alright, and you see, usually a version control system works by having two places to store the things. Right? Does this make any sense here? Version control system works by having two places to store the things. Now, if you observe in this picture, where I am storing the code actually? One is central server, and what is another? Developer's machine. These are two trees. So one tree is your local machine and another tree is your server. Right? So when it comes to two trees, the two trees means two working places. Right? I mean like two storage places. One is working copy, developer's machine, local machine, repository, server. Right? Here your repository is central server. Your working copy is developer's machine. Now if I go back here, so this D1, D2, D3, these are my working copies. This is my working copy. And the working copies are, what do you say, not constant for developer 1, 2 and 3. They are completely different, right? Because developer 1 is implementing some other, what do you say, module. Developer 2 is working on some other module. Developer 3 is working on some other module. But all the working copies of all the developers are going to be maintained under my central server. So this is called my repository. Right? Makes sense? So we are having basically two trees. One is working copy, which belongs to your developers, and there is something called like repository, which belongs to your central server. Right? And you see, working place is where you make your changes, developer changes. Whenever you edit something, it is saved under your working copy. A repository is where all the versions, I mean like your developer 1 version, developer 2 version, developer 3 version, and all this particular code from all the developers is going to be stored under your central repository called repository. Right? So make sense, right? Currently, when you are going with distributed version, centralized version control system, you got only two trees, a working copy and your repository, central server, right? And this only works on two trees, right? Your developer level and your server level, client and server. Now let's see how, so here we need to understand two terminologies. One is called checking out, committing. Right? So checking out is the process of getting the files from repository to your working copy. So what is the use of checking out? So whenever I want to get the files of other developers, imagine that currently I am developer 1 and I want to get the developers 3 file. But where are developers 3 files? Central repository. So getting anything from central repository is called checking out. Right? This is because you can only edit files when it is in your working copy. You cannot edit the files directly on repository. You need to bring them to your local machine, make the changes, again push it back to your repository. right? And when you're done editing your work, you will save it back to the repository by committing it. So what is the process of committing? Committing is nothing but putting back the files which are there in your working copy back to repository. So two operations, very very important: checking out and committing, right? So committing is basically what you're doing. You are getting the files from working, right? So this particular thing to this particular, right? Makes sense, right? Check out and commit process. Now you see two tree architecture. One is working copy, one is repository. So anything you are getting from repository is called checkout. Anything you are putting back to repository is called commit, right? And this architecture is called two tree architecture because you are only having two trees. One is working copy and another is your repository. So this particular two-tree architecture was used by something called like SVN, subversion. So this was a tool which was used very much before to your Git. So before Git, everyone was using your SVN, subversion. But what is the disadvantage with this? I'm getting, yes, single point of failure. So there is single point of failure with this model. So I'm going for two-tree architecture. I'm always going to dependent on my layer. I mean like network layer, power layer, or this particular kind of things, right? That is a problem with this particular approach. Now let's talk about three-tree architecture. This is a distributed version control system. Till now we were talking about centralized, which was earlier to distributed. Right now we are going to the distributed. That's the reason why we are using it. We are using it because it has three trees, right? So here you see you got working a repository, but here you are having something called like staging index. And there is one more thing I will tell you, right? So it says Git uses three trees. One is working copy, and there is an extra area called staging area. Right? I'll talk about what is staging area and where you can use it. Oh, I think like I need to go with the new diagram. Let's see what I can do with the three-tree architecture. So currently I had three trees, right? This is one tree, this is my second tree, and third tree. Right. So what are the other two trees which already seen? We have seen something called like working copy. For the second tree, so this is staging. Here, right? So why I need staging here? I'll tell you, right? So I'll give a small scenario. Let's imagine that currently you are working on one particular project, right? So what is the major advantage of version control system? I can version my files. I mean like what I did at this point of time. Now let's imagine that I was working on one particular project, right? Imagine that it is a web-based application, right? So I was working on a front end. I'm working on front end as well as let's say database. So I'm working on both my front end as well as I'm working on my database changes as well. Right? So what I did, I went with one particular file. Okay, imagine that this is my particular file. So what I did, when I was working on front end changes, I worked with something called like a logo, right? I worked with some logo enhancements when I'm working with the front end changes, right? And I also worked on database related changes. Let's say I changed some password of database, right? Now where I'm working on these changes, local machine. And what area? No. So we got two trees, right? In which tree I'm working currently? Working copy, right? So all these changes, these are happening, right? Now let's imagine there is no staging area. There is only two tree architecture. What you do? You commit these changes, right? So committing is putting from your working copy to repository. Now what you did? You combinedly put this logo and password changes. I mean like your front end and database changes, and you push these changes to repository. I lost my network. Right. So I was pushing the changes from my working copy to repository. Right. But what are the changes I pushed here? Logo and database changes. Right. Now let's imagine this work you did on something like first month. Right. These changes were happened on first month. Now some time went ahead and you are currently under something like third month of your project. You are currently under third word and some time has been elapsed. Now your project manager comes and says he wants to redo the logo changes, right? But version control system, what happened? You have changed logo and password, and at this point of time, this is where you push those changes. I mean, like your front end and back end changes. Now, what he says, keep these changes intact. Don't change password of database. Remain it like that itself. But change the logo design. Earlier logo was on left side. Keep it on right side. Now, what I'll do, I'll go back and I'll revert it, right? Because I know this particular number. But when I do revert, what happens? Is it going to be only logo changes? No, right? Even my password is going to be reset back. Right? One disadvantage. Isn't it? So if I revert it back, I'm not only going to revert logo changes, but I'm also going to revert the database changes as well. That I want to avoid. That is what your staging area is meant for. Right? Directly don't commit to the repository. Right? You have something called like staging. Staging is for modular control. Right? Now what you do is like, first you will work on logo changes on your working copy. Once logo has been done, you'll put it to staging. Right? Then you will commit to your repository. Then you start working on your password as well. You put it to staging. Once you are finalized, then you are putting back to a repository. So what are the things you are going to put under staging area? you'll put all the things which are not finalized. I mean, like, let's say there is still work that is going to be done on your particular thing. That is where staging area is. And whenever you think that work is done, from the staging area, you'll put it back to repository. So whenever you put repository, it means it is shared. Right? So Git works differently. Now here, this repository is not your remote repository. I mean, like, not the central server. This is within your machine itself. In each and every developer's machine, there are going to be three areas. One is working copy and local repository. Right? This repository is not the central repository. This is local repository. Why? Because let's say you worked on one particular file. Right? So what is the disadvantage with my centralized version control system? If there is no network, I cannot work, right? But here, let's say you don't have any network. Do all the changes, push it to your local repository. Right? All the changes are currently available in this machine. And whenever you are getting network, push these changes to a remote repository. Make sense? Now, once your work is done, push it to a remote repository. Now, here, so I'll take one more. So, we're currently having totally 4 areas, actually, right? First is working copy. Then you got your staging area. You got your local repository and remote repository. Right? So, all the work which you are doing here, all these 3 areas are in your machine. These 3 areas would be there for your first developer, second developer, third developer, fourth developer, nth developer. But this is common for everyone, remote repository. So this is your remote repository. This is your working copy. You got staging area. And you got local repository. So what is the work of working copy? Developers code, right? Once this is done, what is the use of staging area here? You can keep the changes here, staging. And if you are finalized, then you can commit the changes to your local repository. Right? So first, from working copy, you are putting it into staging. From staging, you are putting it into local repository. From local repository, you are putting into a remote repository. Make sense? Now, whenever you are putting the changes from your working copy to staging area, right? So this operation is called git add. Right? And if you are pushing the changes from staging to local repository, this is called your git commit. Right? And whenever you want to keep the changes from your local repository to remote repository, right? That is called git push. This particular operation. Right? So take this out. These 4 areas are very, very important. Now, I'll give you one more small example so that it makes very easy for you to remember this as well. So one blind rule is that whenever this is done. So you understood these four areas, right? Now let's say how you can compare it. Now let's do you are doing some shopping, right? You can always compare this example with your shopping example. Let's say you are currently working. I mean, like let's say you are doing some shopping on Amazon, right? So generally, how you are going to purchase the project products? First thing, you'll select some products, right? Let's say this is my one, two, three products, right? You went. Let's imagine that you saw four products. Sorry, four products, right? Now this is like working copy. You can choose anything you want over there, right? Now next thing, once let's say you finalize. I mean, like let's say you want to take something, right? So let's imagine that you want to take product one and three. So what is this thing selecting the products? Where you do generally? You have your cart. You are having your cart, right? This cart is nothing but staging area. Imagine. So you can blindly remember this particular example whenever you are working with Git. So this is your staging area. And from cart, you can come back or move forward, isn't it? Now let's say in cart you want two or one. Let's say only one. You can get back that other project and you can commit that. But let's say you want two products. What you are doing? You are taking this particular cart again forward and you are going for payment, right? You are doing the payment. This is nothing but you are committing. Commit the changes, right? Now once the particular thing, I mean like here payment is done, right? The next thing what is happening, your delivery, right? The delivery you can put it something like a remote repository, or if not, let's say something like you are getting that acknowledgement, right? Your order has been successful. That you can imagine that that is your this area, right? You can always compare this example and know like what is staging area, like what is your working copy, what is your local repository and remote repository. Right, you understood, right? How the changes are moving from one area to another area. Now in Git, only this one is physical. I mean, like let's I close this one. So only this area is physical. This is your virtual memory. This is your virtual memory. This is your virtual. I mean, like these are not visible. The only thing you are going to do is like you are going to physically see is working copy. All these three areas are a virtual areas, logical. So you are not going to see this particular three areas, but I'll show you like how you can view them with the particular commands. Right, till here, is it clear? So what is working copy? What is your staging area? What is your local repository and remote repository? I'll close this. Right, so I'll go to the next slide. And you see the same thing. The difference of Git that sets it apart from other version control system is your staging area. Right? So staging area is a place where you prepare all the things that you are going to commit. Right? In Git, you don't move things directly from working copy to repository. Right? We are having that intermediate area called staging area. Right? So you have to stage them first, then commit the changes. Why? Because you want to have finer control of the things. Right? I took the same example, right? Let's say you got some 8 HTML files which you are doing some logo fixes and two database related files. And staging allows you to finer control exactly. I mean, like whenever you want fine control on, I mean, like front end changes and database changes. That is where we are going for this specific thing. And you see, staging is cache of that file. Cache, temporary, virtual memory. Virtual, I mean like this is not going to be physical. Right, I'll show you like how the terms mean. So this page makes sense, right? So what is the meaning of staging the changes? So whenever you want to keep these temporary changes in some particular area, that is what we are doing with the stage. Right. So you understood it? What is the meaning of three-tree architecture and what are the trees which are there over particular thing? Right. So now, tell me one thing. So let's say you are having two developers, right? So how many working areas I am going to have? How many staging areas I am going to have? How many local repositories I am going to have? How many remote repositories I am going to have? So how many remote repositories? One. Right? How many staging areas? Two. How many local areas? How many working copies? Right? So basically remote repository will be one for one project. But local areas, working copies, staging areas depends upon number of developers you are going to have. Right? And these are the some advantages which you are going to get when you are working with Git. First one is called team collaboration. So I told you, right? So with the help of my remote repository, I can collaborate all the other developers work in one single point. That is my remote repository. Then I have something called like defect tracking. So how I'm going to do the defect tracking? Git has some features with me. Why? Because let's say on one particular file, multiple people worked. Right? Let's say line 1 to 10 has been written by one developer. Line 11 to 20 has been done by developer 2. Line 21 to 30 has been done by developer 3. Now, let's say the defect occurred when the developer 3 worked. So what are the lines which he worked on? 21 to 30. But generally it is going to be tracked by Git because whenever you made some changes, right? You are committing, right? When you are committing, you will give basically your name and email address. I'll tell you like how we are going to do this. So until and unless you are not giving your name and email address, you cannot commit. Right? Whenever you commit, I mean like commit is nothing but putting the change. If you are changing something, right, that change will be going with your username and particular email ID. That's how you can defect track. So whenever you introduce some defects or bugs, it can be tracked. Then you got something called like fast compared to other virtual control systems. So Git behaves differently when compared to SVN and other virtual control systems. So Git basically what it does means it works something like your point. I mean like what you say hard links. We got hard links, right? So what is the purpose of hard links? Whenever you don't want to take up extra memory, right? So basically what is the meaning of version controlling system actually? Now let's say you are having one particular file, right? Imagine from 10 to 20 are one particular line, from 21 to 30, 31 to 40. This is your version 1, version 2, version 3. Same file. Now this is done by your developer 1, 2 and 3. Right? Now in version 1 of your file, like what is the size? Let's imagine from 10 to 20, it was only around like 1.5 kilobytes. If not, I'll change the numbers. 50 from 51 to 100. Right? Now, here, this is going to be my version 2, right? Version 2, how it's going to be there? Two cases. One is 1 to 50 or 21 to 50. Right? The same file with version 1 or only version 2. So Git how it works means, so earlier we discussed something called like the centralized version control system, right? Which is SVN. SVN, it is going to store your this code. I mean like, sorry, this version. It is going to store 1.5 kilobytes. Let's say here it went from 2 kilobytes. Here it was 5 kilobytes. Right? So it is going to store 1.5 kilobytes as well as 2 kilobytes. Changes of version 1 and version 2. But whereas it is intelligent, it will ignore this part of file. It is only going to store the changes from this part. Now here it would be 3.5 KB. But here for my version 2 it is only. Makes sense? That's how Git works. That's the reason why Git is very fast compared to other VCs, because it's only going to store the differences, not the entire list of versioning. Now let's say for this there are 100 versions. If you want to keep 100 versions, there is lots of memory waste, right? That's how your other version control systems behave, SVN, these kind of tools. And you see there is no single point of failure. So we already know what is the meaning of no single point of failure. There is something called like sleek, reliable and secure. So this is the meaning of sleek. So basically it is going to take only these particular changes, and whenever it is pushing these changes, right? So all these changes where it pushing, first it is pushing into my remote repo, sorry, what is a local repository. From local repository I am pushing to a remote repository. Whenever I am pushing the changes from my local repository to remote repository, right, it is going to do compression by default. It will compress, then it will push. That is one more advantage. That's the reason why your this particular thing is going to be very, very less and compared to particular SVN or these tools. And you got something called like open source cross-platform. So you can use Git across different kinds of operating systems and it is completely free. Right? You can go and work with that particular things. Now what I'll do, like I'll just do some comparisons. So let's do some comparison between. This is very important. So whenever you're comparing older versions of system, right? So I'll say Git SVN. So what is SVN? Centralized version control system. Git is my distributed version control system. Let's say there is one some nice comparison. Yes, it says Git is much faster than SVN because I told you, right? Because it is going to store only the differences part. And you see Subversion allows you to check out subtrees because you don't know repos all these things, right? I'll talk about these things later. What is subtree and all this. So you need to have something called like branches concept, then it will make you understand like what are these particular things, right? And you see Git repositories are much smaller than SVN. You see, for Mozilla project, it is almost 30 times smaller. Why? Because I told you, whenever it's pushing, it is going to do the compression as well as it is only going to take the differences, but not everything. Right? And you see, Git was designed to fully distribute from start. Why? Because I got a local repository with me. Right? And you see, Git branches carry entire history. So same concept in branches, we have something called like trunks in SVN, trunks. But here the problem is with trunks is like they will only catch the history from that point of time, not from the existing. Now whenever you create branch, I mean like whenever you're creating trunk from another your what do you say parent trunk, it will not keep the history of it. That's the problem. right? And Git repository clones, sorry, where is that? Provides better auditing of branch and merging. So I'll talk about this particular thing. So what is the meaning of merging? So I mean, like, there are lots of things which we need to say still, but these are the particular differences, right? And Git repository clone acts as full repository backup. Whenever you clone it, you'll get full entire info for your particular repository. Subversions UI is more mature than Git's. Okay, no problem. Right, so basically it is built and it gave like lots of comparison. But basically you can say that these particular things would help you make your dish faster, what do you say, more reliable and more secure as well. Right? So tomorrow what we'll do is like, tomorrow we'll see how we are going to set up, and tomorrow we'll work like developers from tomorrow. For maybe like 3 or 4 days, we'll do all the tasks like how the developers used to work. So we'll do some websites and we'll see like how we are going to work, because we already know like what are the basic tags and all these things, right? So we'll start working like a basic developer and see how we can push the changes, how we can put them in your repositories and all these things, right? So tomorrow we'll see and install this particular Git and how we can start working.